Now we have everything set up to start adding our specific business logic. Here I added a rules.go file under the rules directory that includes the rock, paper, and scissors game logic. For example, we can determine here who is the round winner. So it would be based on the different choices, which is the choice that wins. In this case, for example, if the choice is the same, both choices are rock, it's going to be a draw. If one is rock and the other is scissors, the player A will win, and so forth. These are just helper functions that will help us update our game status when a player performs a move. So make sure you copy and paste it instead of typing it. It's going to be faster for you, and it doesn't make much sense that we go through each of these. So we are going to create now lesson 3 branch to include our business logic. Let's add the rules. Git commit message add rock, paper, and scissors rules. The next step is going to be adding to our keeper the corresponding logic to manage the game state. So we're going to go to our keeper, and we will have to add here, as we have the params, we'll have our games. That is going to be a collections map, where we're going to have our map to be a uint64, which is going to be the index of the game ID, if you want to name it that way, and the game itself. It's going to be a map where we have where the keys are the IDs and the values are the games. Another thing that we are going to add to our state, it's a game number. There's going to be a sequence that will give us the next game number. We're going to keep here the count of games, and every time we create a new game, we will get the corresponding game number from this sequence. To store this in the store, we will need to add some keys for this. So we'll go to our keys.go, and here we can add a games key. Games key. We're going to we have to change this prefix to be unique, so to be 1, and then we're going to have our game number. That's going to be our sequence, our game number key. Let's format that. Now we can remove this, and then when we initialize a new keeper, we should include this as well in here. So the game number is going to be a new sequence, and this new sequence is going to take the schema builder, our key, the game number key, prefix, and the name is going to be game number, human readable name. Similar for the games, it's going to be a collections, new map, and in this new map we're going to include the schema builder. It's always needed. Then we're going to use our key prefix, that's the games key. The name for this is going to be games, and our key is going to be collections uint64 key, and then the value is going to be a codec call value type game types game, and we have to pass here our codec to serialize and deserialize this type in our store. And then we will add a function down here that is going to give us the next game number using the sequence. So it's going to be next game number returns increments the global game number counter. That's our sequence. And it's going to be a function, keepers function, called next game number. It's going to take a context as input parameter, and it's going to return our next game number. That's an int64. We define this, if you remember, in our RPS proto to be the game number as a int64. That's where it comes from. And let's get the current game number. Next, we can use the next function because this is a sequence. And if there's any errors, we're going to panic. There should no error. And we'll return an n+1 because sequences start from 0, but we don't want to store a game with game number 0. So we can add here a comment. Sequence starts in 0, but we want the first game to have game number 1. And this is it for the keeper for now. Next, similarly to how we did with our params in the types, we created this params.go to get the default params and some validations. We're going to do the same with our game store object. So let's create now a file called game.go. It's going to be in the package types. And here we're going to add some default games function. By default games, it's going to return a slice of games. I want to copy games, and we are just going to return because this is going to be empty for now. We don't need any default games on Genesis. So now we can add other getter functions. We can add getter functions for the different fields. Player A and player B are stored as strings, but it would be great to have a getter function to get these as addresses instead of strings. So we can create a small helper function called player address. Get player address, where we will have a string as input, and we'll return an SDK account address, an error, and it's going to be we're going to use this account address from vec32 that takes an address as import, and if it finds it to be valid account address considering our prefix, it will return the account address, otherwise it will return an error. This is important because we can have a different address, for example, from another chain, but here we're validating that it's having our corresponding bec32 account address prefix. So we validate that the players are within our chain. And now let's return the address. And the arrows, we're going to wrap it using Cosmos SDK arrows with we're going to define specific other errors for our module that we are going to include it in an errors.go. Let's split this in another package types. And here we'll define our errors. In this case, we're going to have an invalid address, and we will register this errors register in our modules errors module name, and this is going to be the one invalid address without this dash. This is registering our arrows, and it will have more information about what's the source of this error, right? That corresponds with our module. And this is just like the way to register with a code. This should always be unique. So in our case, it starts with one, but then you will go incrementally with different codes for the errors. So now we can use this error to return error here, invalid address. That's our error. And the address that we received. So we have all the information for this error. And we can use this helper function to return player A and player B addresses. It's going to return account address and error. And this is just going to use our helper function, get player address for the, this should be a function of the game that we can use. It's a game. And let's write here we're going to use player A, that's such a string, and the same for player B address, player B. Another useful functions would be something to get the score of each players. So we're going to use a get player A score. It's going to return 64. Return. Remember that we were going to store this in a score field. That's slice of UN64, actually a tuple. The first field is going to be the player A score, and the second element is going to be the player B score. So this makes it more readable. If someone interacts with this module, knows how to get the corresponding scores for each of the players. And then we also can have some functions to manipulate this score to add a win to the score of each of the players. And we're going to call this add win to player A. It's just a function that will modify the game score for player A to be one more than before. Similarly for player B. but this now the index one. And we can add some validation functions. Mostly when creating a game, we will need these validations. For example, for validating rounds, validate rounds, we should make sure that the rounds are always defined and more than 0, but also less than a max rounds that we can set. So to avoid a game to last forever, let's set a max round constant. Let's say for now that we are going to cap it to 3, just for the purpose of learning, but you can cap it to whatever you want. Actually, you can also put it as a module param, but for now we're going to just keep it here as a constant. So we're going to validate that the game has rounds that are less or equal than the max rounds, but at the same time we want it to be more than 0. We don't want to have 0 rounds because it doesn't make sense. So if it is within the boundaries, it's okay. No error is returned. Otherwise, we'll return an error that we're going to call it rounds out of bounds. And let's define it here. It's going to be our second error. Game rounds out bounds. Next, we can validate. We can add a validation function for the game's moves. If the user have valid moves counts, so let's validate moves count. This is mostly useful when starting from Genesis to make sure that the moves are not more than the rounds. So we can do a simple validation of the game. Player A moves. Player A moves should be less or equal to the game's rounds. Game rounds. And the same for lane B. For player B. Player B moves should be less or equal than the number of rounds. This is just simple checks, stateless checks, right? That's what we in the types folder. And otherwise, we're going to return an error, invalid moves number. And we can register here a new one, new error, invalid move numbers, and we decode 3, invalid player moves count. We can also make a validation for the game number, the ID of the game. We remember that we decided not to have like 0 game number, so we're going to validate that. Validate game number. It's going to return an error if there's one, and we're going to check game. Game number should be always more than 0. This will be okay. Otherwise, we'll return an error, invalid game number. And we add here our error module Let's change this to 4. Valid game number should be greater than 0. We'll get this error message in case of having this situation happening. Next validation would be the status of the game, making sure that the status is a valid status, and we have the valid status defined in our rules. If you go to our rules.go, you will see that we have defined this status, available statuses, and we have this function that we can use here right away. So our validation is going to be easy status here, error, and we're just going to call that function from the rules. Rules is valid status, and we're going to pass our status for the game. If it is valid, no error, otherwise we'll return an invalid game status error. And we can add here, our new invalid error. I'm going to echo 5, valid game status. The next one would be validating the score. If you are going one by one, like the status, the rounds, the player moves, now we're validating the score, and I think that will be enough for the validation. Then we will put all this together. So let's add this validation for the score. Validate score. It's going to return error. Score length cannot be more than the rounds. The score length should always be 2, right? Because we have only 2 players. So if this is more different than 2, we'll return an invalid score error that we have to register here as number 6. Invalid score, and we have to find here the name for it. Invalid score. There we go. Let's format this. This is one case, but also we have to have the total score should be less than the rounds always, right? So let's check that. So if the score of player A plus the score of player B, it's more than the number of rounds, this is invalid, because each round is going to add only one. It's going to even be a draw or somebody wins, and when we win, it's just one point added to the score. So we should never have this situation happening. In such cases, it's going to be an invalid score. There you go. And then otherwise everything's okay, we'll return nil. And now we can aggregate all these validation functions into a main validate function for the game. So we'll validate here all these. So we'll have count A. We're going to get the get player address. We're going to validate that the addresses are okay, but also we want to know that the player A and the player B are different addresses. So let's validate those, that these two are different. This is going to be account A, this is going to be account B, and we're going to check that these are different, account A and account B. should be different. So if they are equal, it's going to be an invalid opponent error that we should add here. Invalid opponent address. Next, we're going to validate the game number. Validate game number. If there's an error, we'll return this. And we're going to do the same with the other fields. The validate status, game rounds, validate game rounds, and validate score. And I believe that's all of this. Let's see. We're validating number, addresses, status, rounds, moves, score. Are we validating moves? No, I think that's missing. Validate moves count. Let's add it here. If error different than nil, we're going to return not nil but error. This is wrong here. There we go. And yeah, we have all our validation functions and some useful getters and setters. So let's continue. So now in our Genesis, under the types, we can add this validation. As you see, we're validating the Genesis state, but we're just validating the params here. And also in the new Genesis state, we're just using the default params. Here we can include the games. We already defined the default games. And here we're going to check if all the provided games are valid. So for this, we'll have to iterate this. Let's do a for game range Genesis state games. These games are stored as an array of games or slice in Golang, and we're going to check if these are valid. And we're going to use the game validate function that we just defined. If we got any errors, we will return this error. But something that we should validate here as well is that you are not having duplicate games in this Genesis. So let's make that a check here. We'll find a unique map where we have the ones that we already saw. And then we'll look here if this already exists in our unique map. Unique game index. We're going to use the game or game number. That should be unique. If we found it, it's a duplicate one or duplicated index, and we'll add this to our errors. A new error that would be duplicated index, and it's going to be number 8, invalid. Let's say duplicated index, game index. So this should be not a string but int. And if here everything is okay, we can add a unique one to our map. equals true. And that's it. We're checking for unique. And similarly, in our keeper, we have to add our genesis to initialize. Using our genesis state, we have the params and the games. So here we have to set our k games set context. We'll have to iterate through all the games and set this. So let's use this game in the range of data games. We're going to iterate all these and we're going to set it. Game number is going to be a key and the game is going to be the value. If there's an error, we'll return an error. And then for the export genesis, similarly, we'll have to iterate through all the games in the store and include it in our exported genesis. So we're going to have an array of games here. Games. It's going to be a types game. And we will have to iterate through our all games. We have a walk function that takes a context, a range. In our case, we're going to range. We don't need a range. We're going to walk through all of the stored games, and our walk function is going to have the game index or game number. Let's call it index for now. It's going to be a int. That's the key of our map, and the value is our game. Game is going to be types game, and this has a stop. That's a boolean, and an error if anything goes wrong. We'll have an error there. And this walk function is just going to append the games to the defined slice previously. So we can do append games and we'll set this game there. If there's any error, we'll return the error. Oh, and we're also returning this nil error. Okay. And this will has to return an error or a boolean, but we have it already defined here, this variable, so we can just return, and it will return this to be false and this to be nil, so it's going to iterate through all our games. We're iterating all of them, we're storing it in this variable, and then we'll have to return in our exported state games. So now we are all set up with the genesis logic and some validation. We can start working on the messages and queries.